How you going? I'd also like to acknowledge the Noongar Menang people, particularly in relevance to Oyster Harbour. So we've got the fish traps. So there's evidence there of these ancient fish traps showing that they've been looking after Oyster Harbour for a really, really long time. And also there's a story I'd encourage you to try and find out about the formation of Oyster Harbour. And it's interesting in relevance to the catchment, because the story actually talks about the Stirling Ranges and the Calgon River, so there is sort of a connection there with the catchment in that actual story and talking about the formation of Green Island. So Oyster Harbour Catchment Group, it's a bit shorter scale, but has been working in catchment management for a really long time. We formed in 1992. And we've had a really wide range of projects, and a lot of them are focused at trying to protect the harbour, including waterway fencing, farm planning, and a wide range of activities. But what I'm going to talk about today is really the work that I've been involved with the Regional Estuaries Initiative, and that's about recognising the harbour as an asset and putting some resources into trying to help farmers change practices to a certain level to try and prevent nutrients, particularly phosphorus, entering into the harbour. Okay, so there's the catchment map. Most of this project is focused in the higher rainfall zone. And in that high rainfall zone, the predominant land use is pasture for grazing. So here's your group of beef farmers at a field day we had the other day, and it was really terrible conditions on Tuesday, but not terrible enough for someone not to be wearing shorts. So they're pretty tough guys, but they care about their animals and they do care about the environment. And what I'm sort of talking about is giving them having a bit more scientific approach to their management practices. Grazing land, as far as a per hectare, nutrient runoff, grazing land is pretty low, especially when you compare to things like urban land use. However, the grazing land is the biggest area land use in this part of the catchment, so that's why it's important to work with these farmers. And really a bit of the science as well is looking into the science of behaviour change and changing practices, and to do that you can look at a bit of a chain of behaviour. So what is the chain of behaviour of a number of things that have to happen to get to the end point where the farmer is achieving his production goal, but only applying just the right amount of fertiliser to do that, and not significantly more. And that way nutrient runoff can virtually, the risk of that is virtually negated. So there's things along that behaviour chain, and one of them is the soil testing program called Whole Farm Nutrient Mapping, which we're trying to get them involved in. It's getting advice, being able to obtain the right product, and then also being able to apply it in a manner that you're actually applying the correct amount that you want. So Whole Farm Nutrient Mapping, the bit more scientific approach is what we're trying to do is, in each paddock, we're actually taking these little dots. Each one is a little core. So we're trying to take 30 cores across each paddock. So as opposed to a lot of sampling done up to this stage, it is only taking a few samples in one spot in the paddock. So we're trying to give a good representation of what's happening in the paddock. And the other thing is trying to represent the results in a coloured map form. So this is the property actually where we were at the field day. It's a bit hard to, I think we're looking at that paddock there. So David Weaver from the Department of Primary Industries tells me of all the soil tests they've done over the years, it's not necessarily that it's a common thing. There's a lot of paddocks around that basically low acidity, plenty of phosphorus, more than enough to achieve the production target, but often deficiencies in sulphur and potassium. And this farm sort of demonstrates that. So that pH is, you know, quite low. And so that's why it's red, because it's like, this should alarm you that you don't really want it to be like this. And you could just about guarantee that some of these paddocks have probably had lime put on them. So here's the phosphorus. So that's all green, sort of meaning that, yeah, there's plenty there. So the number of the fertility index, 2.3, 2.4, you know, if it's 2 or 3, that actually means there's virtually 3 times as much there as the minimum amount required to achieve that production goal. So then we look at, what one have we got here? I can't read it that well. Is that sulphur? Potassium? Okay, so you go to potassium and then we go, oh yeah, there's plenty of phosphorus. There's not much, there's some areas of concern with potassium, and then probably that one with sulphur, we've got some areas. So it's not that even pattern like there is with the phosphorus. So that just sort of shows that, you know, the phosphorus superphosphate, straight superphosphate type, putting 200 kilos on a year is not really appropriate to this farm. And by focusing on some of these other nutrients, there's actually production benefits to be gained by focusing on some of those other nutrients. So at the field day, I was quite pleased to have the agronomist that particular farmer's involved with. So after the soil testing program, the farmers get their results. They have access to an agronomist that we subsidise the cost of that, just especially if they're entering a position where they're for the first time not applying superphosphate if they don't need it. And the agronomists work to the Australian standards of best fertiliser management to work out the areas. And I was quite pleased that the agronomists at the field day told these 61 farmers that there was plenty of phosphorus in this paddock, so they went to a fertiliser product. It did have a small amount of phosphorus in it, but it had the nitrogen and potassium and sulphur in it, so it was good to see that this actually does work. And the farmer had also incorporated lime, so all the things, all the perceived problems that we saw in those maps, that particular farmer in 1 year of doing the program has already started to try and address those. The other thing we do is follow up with a bit of tissue testing. So this is just showing the clover with a little bit of flowering. That's about the time that you want to be doing some tissue testing. And that's just like an extra check to make sure that there's not something missing for the plants. And also particularly for the trace elements, I see there's zinc there looking a bit low and it's been highlighted. So the soil tests don't necessarily give you a good indication of the trace elements. And in fact, with things like copper, you may even have to go to animal testing to give you a better idea of whether you've actually got a deficiency or not. Okay, so one of the things, better speed up a bit, is how do we give farmers confidence to not put superphosphate on, because for them there's a risk that they might not achieve their production. So how do you give them more confidence? And that's the idea behind the uptake trials, which is collaborative between actually fertiliser companies. CSBP is actually putting in the trial, and between DPIRD and Department of Water. So it's trials looking at demonstration. So it's not only checking that the results or the recommendations that we're giving are correct, it's providing a demonstration that farmers can actually see, and also some innovative new methods. There's a pasture reader there, and also using drone footage to assess what's going on with the pastures, as well as more traditional cuts. Simple way of collecting results. So some of these new technologies can be actually calibrated because we've got a trial and we actually know how much pasture's there. That's just a layout of some of the trials. I probably won't go into it too much, but we're looking at different soil types with the Uptake project to see what the phosphorus response is. On this site, actually hadn't had fertiliser for a long time, so it was responsive to phosphorus. Over on this side, you've got the light ones is just phosphorus added on its own, and that's what the growth is. So that's had no phosphorus added. That's had 40 units added, and the dark ones is everything else added as well. So obviously there was a response here to phosphorus, but the response was a lot better when you included everything else as well. And in fact, even at this rate of application, and here, with a small amount of phosphorus, I'll have to go through that. Anyway, it's received a response, but the response is from the other nutrients is actually more than the phosphorus. So I've only got about 20 more slides to go. So this one here wasn't responsive, so basically no matter how much phosphorus you add to this site, you can't make it grow any better. And there's the field day, and that's what we found out. So, but we found out that the recommendations are correct, that if your FertCare accredited advisor tells you don't need to put it on, you don't. And if he says that, there's no production benefit to be gained by adding more phosphorus to a site that's already got plenty. Sounds logical, but there's a lot of production gains to be gained by addressing those other nutrients, whether it's potassium, sulphur or trace elements. And so the other thing is, what does it mean for farmers, is that you do need to do the soil testing to find out, because you don't know if you've got this responsive or not responsive site. So I'll probably just about run out of time. But another thing we've been doing is getting a guy from over east to calibrate fertiliser spreaders. And because at the end, when you get a recommendation and you're only trying to put a certain amount of fertiliser on, if your spreader's not calibrated, then you might be putting 20 kilos in part of the paddock and 300 kilos in the other part of the paddock. So, which is what that this graph is before calibration. So you can see there's a lot of fertiliser coming straight out the back, and the farmer may have been travelling at about 21 metres bout width, and his coefficient of variation was way up here. He was only accurate enough really to be travelling about 7 metres. And after calibration, we got that distance where the coefficient of variation at 15% is out at 25 metres. So by using these trays, testing the machine and doing a few modifications can make a huge difference. Because like this one up the top, if you look at what ended up going on the paddock, it would be going like this, and we need it to be more like this. Especially if we're going from recommending, well, not recommending, but if the farmer's previously been putting on 200 kilos or something, and then we're coming back to 50 kilos, then you want it to be even more accurate. So, okay, last slide. So the harbour and the two harbours virtually, I think there's only two places in the world, Princess Royal and Oyster Harbour, where the seagrass is regenerated. So I'd like to acknowledge Jeff Bastian for all his work in many years for doing that. I'd also not like to acknowledge Heather Adams, our chairperson, for many years' dedication to land care and looking after the harbour, and also David Weaver from the Department of Primary Industries and Regional Development, because a lot of this stuff is his brainchild. Yep, so that's it.